त्याच्यातून आपण स्टेटमेंट म्हणून लिहूयात. ओके, ओके. What are the two statements? त्या नोट्स मध्ये तुम्हाला दिलेलं आहे. ओके, यू कॅन सी. So one remark is there. Okay. Any group of order p raised to n is nilpotent. Okay, which one? First remark. Any group, okay, of order p raised to n is nilpotent group. Okay, for example, suppose the order of a group is equal to 9, which is equal to what? 3 square. Then that implies G is what? Nilpotent. Okay, nilpotent. Suppose the order of a group is equal to 125. Okay, whenever P is prime, okay, any group of order P is 20. So if suppose order of a group G is equal to 125, which is equal to what?
5 raised to 3.
5 cube. That implies G is nilpotent group. Okay, एक सेट एक्झामला असे विचारू शकतात डायरेक्ट शॉर्टकट, हे पटकन सुद्धा. Okay, and now the second notice. A group G is nilpotent if and only if G has a normal series. The group G is nilpotent. The group G is nilpotent if and only if G has a normal series. Okay, has a normal series such that the singleton is equal to n0. Okay, suppose which is subgroup of n1, which is subgroup of n2, and up to so on. This is the subgroup of nm, which is equal to G. Okay, and this ni plus 1 upon ni is contained in the center of G upon ni. Okay, where I running from 0, 1, 2, and up to so on, n minus 1. Okay, that means this is n2 upon n1 for I is equal to 1, which is contained in what? Center of G upon n1. Okay, now this is not only subgroup, this is normal subgroup. Okay, if it is not normal, then we cannot define this quotient with n2 upon n1. Okay, so here the n1 is normal in n2, ni is normal in ni plus 1. ओके, जर G हा माझा nilpotent असेल तर म्हणजे माझ्याकडे अशी एक सिक्वेन्स एक्झिस्ट होईल. Okay, such that ni plus 1 upon ni is contained in center of G upon ni. Okay, so these are the two remarks are there. ऐसे खूप पण दिलेलं आहे. चल वेळ मिळाला तर पुढे नंतर नको, बट इम्पॉर्टंट पार्ट, ग्रुप ऍक्शन ऑन अ सेट. ओके, स्टुडंट किती स्टुडंट आहे? 19 स्टुडंट. तर हा पार्ट समजला नाही तर काहीच समजणार नाही. त्याच्या पुढे क्लास इक्वेशन वगैरे काहीही समजणार नाही. ओके, तर सांगा तुमच्या फ्रेंड्सना क्लास लवकरात लवकर जॉईन व्हायला. ओके, व्हॉट इज द नेक्स्ट पॉईंट? ग्रुप ऍक्शन ऑन अ सेट. Group action on a set. Most important part in group theory in algebra 1. Okay, BSc कोणता आता पण कुठंच ऐकलं नाही आहे तुम्ही ना, हा कॉन्सेप्ट कुठंच वाचलेला पण नसेल. ओके, BSc ला कसं होतं, सिलेबस एक थेरम असेल, 4 एक्झाम्पल सॉल्व्ह केले की मार्क पकडायचे. MSc ला तसं नसतं, प्रत्येक तुमचं थेरम प्रत्येक कन्सेप्ट असतो, लक्षात ठेवा. Okay, example कमी असतात, concept जास्त असतात. Okay, now the next point is group action on a set. Let G be any group. Let's suppose G be any group. Okay, and let capital X be any non-empty set. Any non-empty set. Okay, not necessary that the X is group. Okay, हा X तुमचा काय असायला हवा? Non-empty set असायला हवा. Sufficient. Okay, an action of G. An action of G on the set X is the mapping. Okay, Kai, what is the group action? G is the group, and what is the group action on a set? That is the action of G on S is what? Is one type of mapping such that, suppose this is F is the mapping. Okay, this is the mapping from X cross G. Okay, ordered pair असेल तुमचा input. And what is output? Output is from the set X. Okay, satisfying following condition. Satisfying following conditions. Which conditions? First one, f of input किती असतील तुमच्याकडे ऑर्डर्ड पेअर असेल x, e is equal to x for all small x belongs to capital X. हा कुठून येईल तुमचा इनपुट? या x इनपुट. हा सिंगल हा कुठून येईल? याची इनपुट. ओके, f of x e is equal to x for all x belongs to e, and where e belongs to e कुठून येईल माझा? आहेत का धनशेट्टी, मोरे, साबळे?
Yes, sir.
Where e belongs to? कुठे येईल जालनामध्ये? Okay, f is the function from x cross g to x. Okay, कोणी ऐकत नाहीये मला माहिती. Okay, this x belongs to capital X and this small e belongs to g, capital G. Okay, and the second condition is f of x comma g1 g2 is equal to f of, in the bracket, f of x g1 comma g2. Okay, so all x belongs to capital X, small g1 g2 belongs to capital G. Okay, under this condition we say that this X is the G set, that is the action of G on set X. Okay, under this condition we say जर ह्या दोन कंडिशन सॅटिस्फाय झाल्या तर we say that this X is G set. Okay, X is what? G set or group action on set X. Okay, so what is the note? So first note is that G set X need not be group. Okay, it is not necessary that this X is the group. Okay, look at it. Suppose this is the set X. This is cross. Okay, direct product with set G. Is the mapping F. X cross G2 कुठे गेलाय माझा? हा X cross G2. F is the mapping from X cross G2. X input माझा out X आणि G असेल. Okay, ordered pair. What is output is from X. Okay, so ह्याच्यातनं कुठला एलिमेंट येतो? X. ह्याच्यातनं कुठला एलिमेंट आलाय? Small. Okay, if you apply F is on X comma E, तर हा काय यायला पाहिजे? First condition नुसार X. Okay, and what is second condition? X comma G1 and G2. Suppose these are the two elements from capital G. Therefore, X comma G1 G2 is equal to F of X G1 comma G2. these two conditions satisfy, then we say that this X is the what? G set or group action on X. That is G action on X. Okay, any doubt?
No, sir.
Okay, look at one second. Group action on a set. Let G be a any group and let X be the non-empty set. Okay, X need not be, okay, not necessary to have a group. Okay, an action of G on mapping on X is the mapping. हा एक प्रकारचा फंक्शन आहे. कुठून कुठे X क्रॉस G to X satisfying the following condition. Which one? X f of x e is equal to x and f of x g1 g2 is equal to f of x g1 comma g2. For all x belongs to capital X, g1 and g2 are the two elements belongs to capital G. Under this condition, we say that X is the G set. Okay. Sometimes some author can write f of it nahi x comma is equal to x असे लिहितात direct. Okay, some authors, okay, in some textbook we get this notation x into is equal to x or x in x comma g1 g2 is equal to x g1 comma g2 असं हे मिळतं. Okay, notation. काही ठिकाणी तुम्हाला जर असं दिलं तर घाबरून जायचं कारण नाही. एक्स कॉमा ई इज इक्वल टू और एक्स डॉट ई इज इक्वल टू एक्स असं असेल तर याचा अर्थ हाच असेल. ओके, look at the first example. Example घेतल्यानंतर व्यवस्थित समजेल. Example number 1. Let x is equal to suppose 1, 2, 3 and up to so on. Yeah. Okay, and G is what? G is Sn, that is permutation group on n elements. Okay, that is Sn is equal to what here? G. So define one function. Define one function f from x cross G to, okay, this one is capital X. Okay, and this is the direct product of x and G from capital X by ऐसा डिफाइन केला है फंक्शन में f of याचा एलिमेंट काय असेल इथे असेल x. This is how many elements in Sn? How many elements in n permutation group? How many elements in S3?
6.
Just 3 factorial. Okay. Then
N
how many
factorial.
elements
N
in n
factorial. N factorial.
So this is प्रत्येक किती फंक्शन्स असतील त्यात n फॅक्टोरियल प्रत्येक एलिमेंट तुमचा तिथे फंक्शन आहे. ओके, त्या फंक्शनला नाव दिलं समजा सिग्मा 1 सिग्मा 2 अप टू सो ऑन. ओके, फॉर एक्झाम्पल S3. हाऊ मेनी एलिमेंट्स इन S3? I 1 2 1 3 1 2 2 3 1 2 3 1 3 2. Okay, suppose this is sigma naught function. This is sigma 1, sigma 2, sigma 3, sigma 4, sigma 5. Okay, these are the 6 functions in S3. Okay, G काय माझा? Sn. Okay, each and every element in Sn is one type of function, 1 1 on 2 correspondence. Okay, 1 1 correspondence. So here f of x आणि सेकंड एलिमेंट काय येईल माझा? G नाही येणार, इथे काय येईल? सिग्मा येईल. ओके, सपोज सिग्मा okay, which is defined by sigma sigma. Okay, okay, काय म्हणते माझं फंक्शन x is G सेट कधी होईल माझा? x is G सेट x comma e. ओके, हा एलिमेंट कुठून येतोय माझा? G मध्ये. ओके, मग तिथे G माझा काय आहे? व्हॉट इज G? Sn, permutation group. Okay, so each and every element in Sn is one type of function. Suppose sigma is the function defined by sigma of x. Okay, where this x belongs to capital X and sigma belongs to Sn. Okay, then this set is the G set. This X is the G set. That is the G group action on a set X. कसा होईल? For example, 3 साठी घेऊन बघूयात काय होईल. Okay, wait. Suppose X is equal to 1, 2, 3. Okay, and what is S3? S3 काय येईल माझा? Okay, हा n इथे आहे, तोच n इथे आहे बरं का. Suppose X is equal to 1, 2, 3, and S3 is equal to what? Identity, that is 1. Okay, 1, 2, 1, 3, 2, 3, 1, 2, 3, 2. Is it correct? Okay, suppose this sigma 0, sigma 1, sigma 2, sigma 3, sigma 4, and sigma 5. Okay, यानुसार काय येईल माझं मग? Suppose take any element, X is equal to 2. Okay, so f of 2, आणि हा कुठून येतो? एक sigma belongs to Sn. So take the any element of S3, sigma 1. Okay, suppose sigma 1. कसा डिफाइन केलाय हा? sigma 1 of 2. ओके, sigma 1 मध्ये 2 ची इमेज किती आहे? सॉरी, sigma 1 मध्ये 2 ची इमेज किती आहे? What is sigma 1? 1, 2. ह्याच्यामध्ये 2 ची इमेज काय आहे?
1.
सांगा ना. ओके, सो दिस इज, सो हियर f of 2 sigma 1 कसा डिफाइन केलाय हा? 1. Okay, suppose X is equal to 3 and sigma is equal to sigma 5, suppose. Okay, get that. हा काय येईल मग? f of 3 comma sigma 5 is equal to, by the definition this is sigma 5 of 3. Okay, in sigma 5 what is the image of 3? What is the image of 3 in sigma 5? काय sigma 5 is equal to 1? सांगा ना, बोला फक्त. त्यांच्यासाठी काय इमेज? वर्षा अदवत, मुस्कान पटेल, आहात का तुम्ही? यस और नो हे तरी म्हणा.
1.
सांगा ना. 3 ची इमेज किती?
1.
3 ची इमेज 2 ना, इकडे 1 ची इमेज 3, 3 ची इमेज
हा, yes sir, 2. इमेज 2 येते.
2 असा डिफाइन होतोय हा फंक्शन. ओके, इन जनरल हा कसा होईल मग? ऑन द सेट containing n elements, Sn contain n factorial elements. Okay, defined by f of x sigma is equal to sigma x असा डिफाइन केला. Okay, any doubt up to here?
No sir.
So this f is what? So now here this x is the G set. कसा फॉर्म होते G set? दोन कंडिशन सॅटिस्फाय करतात का बघूया. कोणत्या दोन कंडिशन वरच्या? ओके, f of x sigma is equal to sigma x. Okay, first condition. Then what is first condition? f of x comma e is equal to e x अलावा. ओके ओके, e म्हणजे काय? तुमचा आयडेंटिटी एलिमेंट ऑफ ग्रुप. व्हॉट इज द आयडेंटिटी एलिमेंट ऑफ Sn? sigma naught. Okay, since suppose this sigma naught is identity. Okay, identity element. Suppose this one is identity element. That is sigma naught of this one is sigma naught of x. Okay, identity element मध्ये x ची इमेज काय असते? 1, 2, 3. Okay, for example 3. 1 ची इमेज 1, 2 ची इमेज 2, 3 ची इमेज 3. Yeah, suppose this is sigma identity. Okay, of S3. What is the image of 1? 1. Image of 2? Image of 3 is 3. So what is the image of sigma s x here? X. Okay, so that implies f of x sigma naught is equal to x. Okay, now first condition holds. What is second condition? This one. F of x g1 g2 is equal to f of x g1 comma g2. Okay, f of x comma. Okay, instead of g1 g2 इथे काय लिहिलं sigma 1 and sigma 2 suppose. Okay, it's equal to is equal to. By the definition, this is sigma 1 into sigma 2 of x. Okay, so this is equal to काय होईल हा कसा आपला होईल आधी सिग्मा 1 आपला होईल त्या x. Okay, then sigma 2. So this will be sigma 2 of sigma 1 of x. Image of x under the sigma 1. That is sigma 1 of x. Okay, जो काय आउटपुट येईल then image of sigma 1 of x under sigma 2. Okay, so this is sigma 2 as it is. What is this one? By the definition of f of x sigma 1, which is equal to, again by using definition, this is f of this is the first coordinate x sigma 1, and this one is sigma 2. Hence, capital X is G set. Okay, what is capital X? X is equal to 1, 2, up to so on n. Is which set? G set, that is the ascent set. Okay, any doubt?
No, sir.
No, sir.
Second example. माहिती नसेल कळत नसेल तर विचारा बरं का पुन्हा सगळं संपलं तुम्ही त्यावेळी म्हणतोय मी काय अडचण नाही. जर ऐकत असाल तरच कळेल ना. सेकंड, सपोज G is group. Okay, and capital H is subgroup of capital G. Okay, suppose this is G. This one is what? H. Okay, instead of H, normal subgroup of H. What is R? R is equal to. Then this R is equal to set of all right cosets. Cosets म्हणजे काय? Of H in G. Okay, what is cosets are indicator? This is G by H is what? Quotient. Okay, so H is normal in G, then we can define this quotient group. Okay, G by H. Okay, what is the nature of this set? Right quotient म्हणजे this is HA, where A belongs to G. Okay, suppose order of what is order of G by H? Equal to order of G by order of H. Okay, समजा या ग्रुपची ऑर्डर आहे 10. H ची order of G is 10. Order of H suppose 2. What is the order of G by H?
5.
5. म्हणजे this is the number of cosets in G. Okay, so R मध्ये किती एलिमेंट्स असतील माझे? 5 ना? Order of G by order of H. Okay, so collection of all the right cosets. असे डिस्टिंक्ट किती मला कोर्सेस मिळतील? 5 cosets मिळतील. Okay, so R is what? Set of all right cosets of H in G. Okay. So here, this is the set R. Okay, this is only set G. Okay, F is the mapping from R cross G to R. Sorry, R. Okay, X cross G to X ना मग इथं X तुमचा काय X is equal to R. R cross G to R. Then consider this F from R cross G to R. Define the y. कसा डिफाइन केलं? डिफाइन बाय एफ ऑफ याच्यातला प्रत्येक एलिमेंट कसा असेल माझा? हा जी बाय एच असेल ना. एक सेट म्हणजे एक एलिमेंट म्हणजे जी बाय एच. ओके, कलेक्शन ऑफ ऑल द राइट्स कोसेट्स ऑफ एच इन जी. ओके, असं असेल म्हणजे याच्यातलं एलिमेंट कसं असेल माझा? एच ए किंवा एच एक्स, वेअर दिस एक्स बिलॉंग्स टू capital G. Is it correct?
Yes, sir.
Okay, so then this f of hx comma g, this is g, is equal to h x small g. I will tell you. Okay, and this is the limit h x small g. Okay, this x belongs to g, this small g belongs to g, so x into g belongs to capital G. म्हणजे ह्याच्यातलं एलिमेंट कसं आलं? याने okay, defined by this one. So what is the first condition? First condition of x set of G. X G set. X is a G set. That means first condition here is hx into hx comma small. By definition, what we get? Uh, hx belongs to R and small x belongs to G. So this is x, hx comma e. Okay, x into e, x into e is x. Okay, so first condition satisfied. What is second condition? F of hx comma g1 g2. Okay, hx comma g1 comma g2. Okay, so which is equal to this is h x g1 by using associative property now in g. Okay, into g2, which is equal to what? H x g1 comma x g2. Which property is HAB is equal to HA into HB. It is equal to this is what? F of HX G1 G2. Okay, has a fixed level x into G1. It is equal to F of this is the definition of F of X G1 in comma, and second condition also holds, implies R is G set. Okay, collection of all the cosets, right? Cosets of G is the G set. Okay, any doubt?
No, sir.
No, sir. Of course.
Third example. Okay, instead of taking x, x is equal to g into the guy. Okay, f is the function from g to g. Okay, take here capital X. Okay, capital X has any non-empty set. So here G is the group. That means it is non-empty and it's set. Okay, so put other than set this G is a group. Okay, so F is the function from G to G to कुठेही माझा हा G. Okay, so G is itself G set. Okay, G is itself G set. असा डिफाइन केला आहे defined by f of x comma g is equal to xg, where all small x belongs to capital G, small g belongs to capital G. Okay, first condition है f of x comma e is equal to different color, this is x into e. Okay, by the definition of this f. So x into any identity element into x, any element. So this is x, first condition satisfied. It is f of x g1 g2. And by the definition, this is x into g1 into g2, which is equal to x into g1. Okay, associative property in g. And what is this one? f of x g1, okay, comma g2, okay, sorry, into g2. This is equal to what? F of x g1 into g2. This is the definition of f of x g1 comma g1 comma g. And second condition also holds. Any doubt up to here? So g is
Yes, sir.
itself g set. Okay. So remark is that look at that. Remark is that. Suppose let this capital X be a G set. Capital X be a G set. Okay. That is in the notation and write X is G set notation under the action of F. Under the action of small f. Okay, so by definition, if suppose x is the G set under the action of f, so by the definition what we have, if this capital X is G set, then there exists a function f from x cross G to capital X such that first condition f of x comma e is equal to x for all x belongs to capital G. Sorry, capital X. And second one, f of x comma g1 g2 is equal to f of x g1 comma g2 or x belongs to capital X, g1 and g2 belongs to capital G. ओके म्हणजेच x हा जर g सेट असेल तर ह्या कंडिशन exist होती. Okay, there exists a function f from x cross g to x such that these two condition holds. Okay, if these two condition holds and there exists a function f from x cross g to x such that these two condition holds, then x is a g set. Okay, so any definition, okay, is in the if and only if form. Okay, for example, जर g जर माझा अबेलियन असेल तर काय असतो a dot b is equal to b dot a for all a b belongs to G. Okay, if G is abelian, this condition holds. If this condition holds, then G is abelian. So any definition, this is implies and implied statement. Okay, so any definition, कोणताही definition घेतला तर तो implies and implied या दोन्ही true होत असतात. Okay, that if G is abelian, then this condition, if this is true for all element, then G is abelian. Okay, this सांगितलं पुढे. Okay, if x is the G set, then this condition true. This true condition with existence of function x cross G to x. Okay, any doubt?
No, sir.
Okay, so here the some authors use the notation. काही authors काय करतात x cross e, f of x e हे असंही लिहितात. x. Okay, that means f of x g जर असेल तर हे डायरेक्ट काय करतात x g x into g असे लिहितात. ओके, f लिहित नाही. त्याचाच अर्थ काय आहे? ओके, and हा नोटेशन कसा आहे? Some authors use f of x g1 into g is equal to x g1 g2 असे लिहितात काय. ओके, असं का सांगतोय? काही ठिकाणी पुढच्या थेरममध्ये हा यूज केला आपण. ओके, ते कन्फ्यूज होऊन नये. Okay, any doubt up to here?
No, sir.
Now, the next point, stabilizer of a group. Okay, stabilizer subgroup or isotropic subgroup. Okay, collection exit. Define inside here. Define a set. Okay, what is that set? G capital X small. Okay, first consider X be a G set. X be a G set. याचा अर्थ काय there exists a function f from x cross g to x satisfying these two property. Okay, जिथे जिथे हा स्टेटमेंट येईल. Okay, we assume x there exists a function f from x cross g to x such that these two condition holds. Okay, so here the x is G set. Okay, now take small x belongs to capital X. Small x belongs to capital X and fixed it. Okay. Small x belongs to capital X and त्याला काय केलं आपण fixed केलं. Okay. So for this fixed x, for this fixed x, we can define one set. Which set? Capital G into and the suffix small x. What is the nature of this set? Look at here. Collection of those elements belongs to the G such that f of x comma g is equal to x. That is x into g is equal to x. Okay, what is gx? This one is capital X. Need लक्ष द्या. And this one is capital G. X is what? G set. Okay, so x I fix केला आहे. Belongs to capital X. And we define this set gx. कसा define केला आहे? Capital G small x. Collection of those elements belongs to G. Okay, this is G belongs to capital G. म्हणजे हा gx काय येईल माझा? या capital G चा subset. Okay, is it correct?
Yes, sir.
Collection of those elements belongs to G such that x comma g is equal to x. म्हणजे या g चा या x सोबत जर प्रोडक्ट घेतला तर तो काय येईल? x. ओके, या x चा या प्रत्येक एलिमेंट या gx मधल्या प्रत्येक एलिमेंटचा जर प्रोडक्ट घेतला तर काय होईल? तो x हा xच येईल. Okay, and the collection of that those elements belongs to G. It's called as Gx. Okay, so this set is what? Gx. Look at it. Gx is nothing but collection of those elements belongs to capital G such that f of xg is equal to x. Okay, that is x comma g is equal to x. Some author use this notation. Okay, any doubt?
No, sir.
And another set, one more set is there. Capital X, small g. Okay, what is capital X small g? Which is equal to, wait a minute. Capital X small g. This is the subset of capital X. Collection of those elements belongs to capital X such that f of x comma g is equal to x, or that is x into g is equal to x. ओके, आता इथे काय केलं या सेटमध्ये? नंतरच बघू. Okay, so what is gx? Gx is called as this set is called as, okay, this set forms the subgroup of G. Gx काय होतो? या G चा subgroup तयार होतो. Okay, याचं group पण बघूया. And that Gx, capital G, small x, is called isotropic subgroup. Isotropic subgroup of G or stabilizer subgroup. Stabilizer subgroup of capital G. Okay, any doubt in this definition GX?
No,
हा
sir.
एक्स तुम्ही फिक्स केलाय तुम्ही. ओके, हा फिक्स आहे एक्स तुमचा. एक्स तो एक्स इंटू एनी एलिमेंट ऑफ जी एक्स. समजा माझा एखादा जी जर माझा ह्या जी एक्स मध्ये असेल तर काय याचं कंडिशन याचा अर्थ काय? एक्स इंटू जी इज इक्वल टू एक्स. इज इट करेक्ट? म्हणजे हा जी ही कंडिशन सॅटिस्फाय करते विथ दिस एक्स. ओके,
Yes, sir.
collection of those elements belongs to G such that x into G is equal to x. Now fix the G. Okay, suppose this is capital X. This is capital G. And F is the function from x plus G to x. No? Okay, and now this one is G is fixed. Okay, G is what? Fixed. So what is capital X, small g? Is the collection of those elements belongs to capital X such that f of x comma g is equal to x. That is x into g is equal to x. Okay, for all fixed. G fixed money. This means for all small g belongs to capital G. Okay, so here g is not fixed. So this capital X small g collection of the elements belongs to x. जे हा मतलब कोणाचा सबसेट आहे? X चा सबसेट. Okay, this is capital X small g. The collection of those elements belongs to x which satisfy this property for all g. All g. Okay, x1 आहे म्हणजे काय म्हणजे x1 into g is equal to x1. Suppose x1 x2 is contained in x2 belongs to g, so x2 into g is equal to what? x2 for all g belongs to capital G. Okay, समजा या xg यामध्ये माझा दोनच एलिमेंट असतील x1 and x2. That implies what? This x1 into this g is equal to x1. x2 into g is equal to x2 for all g belongs to capital G. Okay, any doubt up to here?
No, sir.
Sir.
Okay, so these are the two concepts. In the next lecture we will see how this gx is forms a group. Okay, हा stabilizer subgroup म्हणतो ना, हा group कसा तयार होतो हे सांगा. Okay, next class. So for today it is sufficient. Okay, any doubt up to here?
No, sir.
No, sir.